I used to go to a field, collecting plants, following monkeys, taking notes about behavior, small scales in time and space. And now with my PhD, now I have gone more from that empirical to more analytical and bigger scales like regions of continents and millions of years. And I have also brought more programming skills. So yes, it's a way to put all the best of those two worlds together. Hola, mi nombre es Francisco Henao Diaz, soy estudiante de doctorado en el laboratorio de Pennell. Trabajo en macroevolución, biogeografía. Estoy interesado en gradientes de elevación especialmente y los patrones emergentes de la evolución que se pueden recuperar de árboles filogenéticos. So macroevolution is the evolutionary processes or changes that occur above the species level. So modifications that occur for species, genera, and phyla, for example, and that usually take millions of years and occurs at big geographical scales like regions or continents. A phylogenetic tree is an evolutionary hypothesis that tries to show us or to reconstruct the evolutionary history of species. It kind of depicts the relationships between species, which ones are closer to the other ones, and most of them, or the ones that we have been compiling recently, also have times. So we can also infer not just how related are species to each other, but by how long or when was the last ancestor of those groups. And we can also correlate that with climatic information, their traits, or geographic distribution, for example, to try to go for the main drivers of how biodiversity is, how it is on Earth. One of the main features of biodiversity on Earth is that groups have different numbers of species. And biologists have been wondering what's the main reason of that. And one of the hypotheses that we have been working on is that the amount of species per unit of time, or speciation rate, is the responsible for those inequalities. So we think, or we have been thinking, that groups that have more species have higher speciation rates, for example. So what we figure out is that we cannot compare groups that have different ages. So we can explain the differences between mammals diversity and insects diversity, even though they have different amounts of species by their speciation rates, because insects are much older than mammals. So what we figure out later on is that with some mathematical treatments, we can account for those differences, and maybe in the future we might compare their speciation rates and explain why insects might be more diverse than mammals. Diversification rates or speciation rates hold the promise to explain things in microevolution, but we might need to be more careful about them. And that happens with many of the tools that we have had in science. We need to be very critical about the tools and the methods that we use and the limitations of the inferences that we can take from them. What I have been doing through my grad school is trying to understand the tempo and mode of evolution across different timescales and spatial scales. And by doing so, we have uncovered some generalities about macroevolutionary patterns, and that has opened many other questions and interesting avenues to understand why life on Earth is so diverse.